This is section 7.2, and today we're going to be talking about the converse of the Pythagorean theorem. So in the last lesson we were talking all about a squared b squared equals c squared, and that works when you have right triangles. So now we're going to talk about what happens if you don't equal, if a squared plus b squared does not equal. So just a quick recap, our a squared plus b squared equals c squared. When that does happen, then our angle is 90 degrees, which makes it a right triangle, and that's what we've been working with so far. But if a squared plus b squared is less than c squared, so if that third side, that hypotenuse, is actually bigger than these two sides, what you end up with, oh shoot, I did that in the wrong, hold on, just white that out. I have these backwards. Make that a greater than symbol. So if your two sides are bigger than your hypotenuse, so if the sides beat the hypotenuse, then that's an acute triangle. Sorry, I did the wrong one first. So if your two sides are bigger than your what should be your hypotenuse, if the two littlest sides are bigger than your third one, then your angle is less than 90, and you have an acute triangle. If this time your c squared is bigger than the other two sides, so imagine that this side is really, really long, it's kind of stretching these two sides out, makes that angle even bigger, so it's going to be over 90, that will be an obtuse triangle. And that is a B, but it's terrible. And we're just going to do a couple of examples with those, deciding what kind of triangle we have each time. So it says classify the triangle. First we have to figure out which side is the longest. And I don't know how long 3 square roots of 34 is. Even though it looks like it should be the hypotenuse, we want to go in and see how big it is. So I'm going to do 3 square root of 34. And it is 17, so that's the biggest side. So what I'm going to do is set up Pythagorean's theorem with 9 squared, 15 squared, and I'm going to put a question mark above that, and we're going to have 3 square roots of 34 squared. I don't know if it's equal or if somebody's going to be less than or greater than. So my 9 squared is 81, 15 squared is 225, and then 3 square root 34 squared. So there's a couple ways you can square that. So I already figured out what this is as a decimal, and at this point, no matter what calculator you have, I just want to hit the squared button, mine happens to be right here, so that you square this whole answer. If all you do, I'm going to write that down because I'm going to keep typing here. If all you do is take 17.49 and square it, you're going to get something else. And even though those are close, you're deciding if they're equal. So if you have a decimal over here and this side's not a decimal, then they're not equal. So you might end up getting an answer that's not actually true. So make sure you're using the whole decimal. Another way to enter it would be to actually type that in parentheses and then square it. And your calculator can do that for you too, and it'll be 306. So you want to really be careful when you're doing this particular section that you are watching, especially when you have a square root, that you are squaring the correct number. So 81 plus 225 is going to give us 306. So it looks like these are in fact equal. That means that this is a right triangle. Next one, 26 is supposed to be my C side because that's the longest one. So I'm going to do 22 squared plus 14 squared equals 26 squared. I'm going to put a question mark. We're going to check it out. 22 squared is 484. 14 squared is 196, and 26 squared is 676. So 484 and 196 actually gives us 680. So it looks like the two sides, the two smaller sides, were bigger than the third side. That makes this an acute triangle. Last one, I've got 5, 6, and 9. So 5 squared plus 6 squared, and we're checking to see how does it compare to 9 squared. So 25 plus 36 and 81, that's a 25. Looks like this is going to be 61, and that is less than the 81. So that means your hypotenuse 1, it's really big, which makes it an obtuse triangle. A couple more just word problems this time. It says, can the segments of 4.3, 5.2, and 6.1 form a triangle? So remember we had talked about last semester that the two smallest sides have to be bigger in order for you to even have a triangle. So that would be 9.5. So yes, we have a triangle. Now they want to tell what kind it is. So I'm just going to square these now, 4.3 squared and 5.2 squared, and I'm going to compare that to 6.1 squared and see where we land. So 4.3, 5.2, and we're going to compare that to 6.1 squared. So it looks like the two sides were bigger. That makes us an acute angle. Last one, can those segments make a triangle? Again, I want my two smallest ones have to be together and my third one by itself. So 6.5 and 7.1, yep, they're bigger, so that means that I have at least a triangle. Yes, a triangle. Now we need to know what kind. So 6.5 squared and 7.1 squared, and we're going to see how that compares to 11.2 squared. So first we're doing them not squared, just the two smallest ones. We're making sure they beat the third side. And then we're squaring them all to figure out what kind of triangle do we have. This side's going to be 91.25, and 11.2 squared, 2 squared is 125.44. It looks like the hypotenuse 1, so that makes an obtuse triangle. So just got through those three different types of triangles that can be made with a check on Pythagorean's theorem, deciding if the two sides are bigger than that C side or they are not.